Hi, today we are going to teach you about curve sketching. This is a huge part of calculus and how you use the application of derivatives. First, we will start with the function x to the 5th over 20 minus x to the 4 over 12 minus 4x cubed over 3 plus 6x squared plus 5x minus 2. The first step in curve sketching is to find the first and second derivatives of the given function. First, we will start with the first derivative of the function. Next, we will find the second derivative of the function. For the second derivative, this will give us possible points of inflection for the function, as well as where the function is concave up and concave down. And for the first derivative, these points are possible minimum and maximum of the function. Now that we have found our possible minimum, maximum, and points of inflection, we will put them into a sign chart to see if the points found actually mean anything to the graph. For the second derivative chart, when the sign is negative, that means the graph is concave down within that domain, and where the sign is positive, that means the concave up is in that specified domain. To find these signs, we will plug in different numbers to the second derivative as shown at the right. In this instance, we plugged in the numbers 2.5 and 5. Not only this, but when the sign chart goes from a positive to a negative, or from a negative to a positive, there's a point of inflection on the graph. This just means that the graph changes concavity at these points. On the first derivative sign chart, the positive and negative signs tell us where the graph is increasing and decreasing. This will help us later on to sketch the graph. Whenever the sign chart goes from a negative to a positive, that is a minimum on the graph, and where the sign chart goes from a positive to a negative, there is a maximum on the graph. To find these signs for each interval on the chart, you would again plug in numbers, but this time into the first derivative. We're not going to show you the work to save time, but this is what you should get when you would solve it.
Using the sign chart from the first derivative, we can see where the graph is increasing and decreasing. As shown on the chart, we can see the graph is increasing on the intervals -3 to -2, -2 to 0, and 5 to infinity. We know this because the sign chart is positive at these intervals. Similarly, we can find the decreasing intervals where the intervals on the sign chart are negative. In this case, it would be -infinity to -3, 0 to 2, and 2 to 5. Now, using the sign chart from the second derivative, we can see where the graph will be concave up and concave down. The intervals in which this particular graph is concave up is -2 to 2 and 3 to infinity. We can tell this because our sign chart is positive here within these intervals. From here, we can also see where the graph is concave down based on where the sign chart is negative. In this instance, it would be the intervals -infinity to -2 and 2 to 3, where the graph is concave down. Now using this information, we're gonna find the graph to this equation. We're gonna curve sketch. Right now I am blocking out where the equation is increasing on the graph just to make it a little easier. You can do this if you want, it's not really mandatory, but it just makes it a little easier to see and use the information to create your graph. And the same thing I'm going to do is mark where it's decreasing. You can see in the top I wrote that you already have the information too, so if you can't really see it that well, then just look back earlier in the video. Also marking where it's concave up. And then I'm marking where it's concave down. And then using that, you can write out your sign charts again, find your points of inflection, which is what I'm writing right now. Up top on the first derivative, I have the relative mins and maxes, where it's decreasing to increasing, it's going to be a relative min, and increasing to decreasing is going to be a relative max. So the relative max is going to be at x equals 0, and then I'm using that point of inflection there, inflection at 2. Then we have our relative min at x equals 5. I'm also using the rest of that to figure out the other side of the graph. It's symmetrical. Doesn't really matter how high you make it, but as long as you got that relative max and those relative mins, you're good.